Hello everyone, welcome to Robert Morris University Math 0900. This is Brianne Pernick. We are now going to work on Chapter 2, Lesson 5. In this chapter, we are going to learn how to solve formulas for specified variables. There are no new terms for this section, and this section can sometimes often come off as being very abstract to some people and hard to understand why we must do what we're going to do. Let me just kind of state that when you are asked to solve for a specific variable in an equation or in a formula, the reason that you would want to do this is because it is significantly easier to manipulate an equation or a formula using variables than it is to manipulate that equation or formula once you have substituted in numerical values. Once you substitute in those numerical values, you are then required to do the mathematical calculations step by step by step. Sometimes you have to round, which is going to cause you to lose accuracy from line to line. And it's just plain and simple going to make your problem harder for you to have to carry numbers from line to line and do those mathematical calculations from line to line than it would be to just bring your variables down. So we do teach this lesson to teach you how to manipulate a formula and an equation to solve for a given variable so that you can make your equation solving simpler. Now, when you're solving for formulas, it will require us to solve for a specific variable. And similarly, when you are solving what is called a literal equation, which is not necessarily a formula, but maybe an equation that has multiple variables in it, and you're being told to solve for a specific variable. Okay? When you're asked to do this, you simply have to keep in mind that every other variable or all of the other variables, depending on the situation, that are in the equation are simply to be treated as if they are a number. If you keep that in mind, then you can manipulate your formula or your literal equation exactly as you would for any equation that you already know how to solve. Okay, so you have to get in the mindset that variables behave exactly the same way that numbers behave. Variables are placeholders for numbers. They represent numbers. They're just a placeholder. And for that reason, we can allow them to be manipulated exactly the same way that numbers can. So let's look at these first couple of examples that we have here. We have that American Airlines recently scheduled a nonstop flight in a new Boeing 777 jet from Chicago to London. The approximate air distance traveled on the flight was 3,975 miles. The average speed of the aircraft on the trip was 530 miles per hour. How many hours did it take the Boeing 777 to fly this trip? What you're going to work with here is the distance formula. So let's start there. For those of us who don't know what the distance formula is, it is distance equals rate times time. D equals RT. We often call this formula the DIRT formula to help us remember it because it kind of looks like it spells the word dirt. Now, we could very easily plug in our mileage for the distance, our speed for the rate, and solve for t, because we do know how to solve a one-step equation. However, I want to teach you how to solve for t first and then plug in your given information. Because the question says, how many hours did it take? So that's an indication to you that you are solving this formula for time. Right now, your equation is solved for distance. We don't care about distance. That was given to us. What we care about is time. So let's isolate time before we even begin doing any type of substitution. So we ask ourselves, what is happening mathematically between r and t? Well, when two variables are beside each other, that means that they're being multiplied. So to undo multiplication, we need to divide. And since I want to isolate t, I'm going to divide both sides by r. That will cancel r and leave me with t. And then on the left, I have d over r. That means that when I want to solve for t, for my time, all I have to do is take my distance and divide it by my rate. So my distance was 3,975 miles, and my rate was 530 miles per hour. So I'm simply going to divide those. Go ahead, take a second, plug that into your calculator. 3,975 divided by 530. We should get 7.5. That means that it took the airplane 7.5 hours to fly this trip. So you would just want to write a nice little sentence there so that you answer the problem correctly. You always finish a word problem with a sentence. So we would just say it took 7.5 hours to fly from Chicago to London. And you would finish it off with your sentence. Letter B, we're going to approach exactly the same way. A flight of 1,550 miles from Boston to Dallas takes 4 hours. Find the airplane's average rate of speed for that flight. So we're still working with the distance formula, D equals RT, but this time they want to know the rate. Again, the original formula in its original state is solved for distance. Essentially, I don't care about distance. I'm being asked to find the rate of the problem. So before I do any substitution, I want to manipulate this formula in order to solve it for rate. So rate times time In order to undo multiplication, I must divide both sides, and I'm going to divide it by time so that I can isolate rate. So I have d over t equals r. Now that I have my formula solved for r, I can go ahead and plug in my given information. So distance was 1,550 miles. Time was 4 hours. And now all we have to do is a simple division. When you plug that in, you should get 387.5 miles per hour. So you would just finish that off by saying the plane's rate of speed was 387.5 miles per hour. You always want to write a sentence to finish a word problem. Okay, now what we're going to look at next are a series of literal equations. This just means that you're being given an equation that contains more than one variable, and you're being asked to solve for a specific variable. Letter C, we've actually already done. They want us to solve for t. We did this. We knew that we have to divide both sides by r, and d over r gave us t. What we need to do now is letters D and E. I'll walk you through letter D, and then I would like you to try letter E on your own. Now, as you're working through these literal equations, what I need you to remember is that each term should be treated as if it's just a number, okay? If you remember that, then you can manipulate each term the same way that we manipulate every other term as we're solving equations. Now, we want to isolate y, so I'm going to draw a little arrow above it so that I remember that that y is what I need to isolate and get by itself. So I ask myself, I have addition of 3x and I have multiplication of -2. What do I have to undo first in a two-step equation? Addition or multiplication? I'm supposed to undo addition. So the first thing that we're going to do is subtract 3x from both sides. That's going to leave us with -2y equals -3x plus 6. Lastly, we have -2 times y. To undo multiplication, we divide. Note that I divided my whole right side by -2. I drew one big fraction bar. On the left, my -2's cancel, and y is isolated. Now, I'm going to divide each term by -2 right now. So I have 3/2 x, and 6 divided by -2 is -3. And I have now solved my equation for y. I would like you to go ahead and try letter E, solve it for y. That means that you're going to isolate that equation for y. Pause the recording. When you're ready, go ahead and press play and we'll check our answer. Okay, at this point, you should be ready to check your answer for letter E. We are working to isolate y. You could approach this two different ways. You could have said, well, I am adding an 8 and a 3x to my term of negative 2y. And you could have chosen to subtract them from both sides. So let's do that here. We're going to subtract 8, and we're going to subtract 3x. What we do to one side, we have to do to the other. That leaves us with negative 2y equals negative 8 minus 3x. Next, we want to divide both sides by negative 2. Y equals, now we're going to divide that negative 2 to each term in that numerator. Negative 8 divided by negative 2 is 4, and negative 3 divided by negative 2 leaves us with positive 3 halves x. So the first way that you could have solved that equation was by subtracting the other two terms away from your y. Okay, if you did it that way, that's okay, perfectly fine. Now, some other people may have approached this differently, and I'd like to show you another way to do it. Some people would look at that and say, I have my positive 8 and my 3x on the left, and I just have my one y term and a 0 on this side. So some people would choose to add 2y to both sides, and that gives you 8 plus 3x equals 2y. The reason that some people choose to do that is because the right-hand side is equal to 0. By moving the 2y, you're only moving one term. So it's less manipulation, less math to do. Then you're dividing both sides by 2. You still have to divide to each term in the numerator. 8 divided by 2 is 4. 3 divided by 2 is still just 3 halves x, and that equals y. So we have the same exact answer that we had before, two ways that we could have solved it. Either way that you chose to do it would be correct as long as you had the right answer. Right. One final example for this section, and we're told that a trapezoid is a four-sided figure with two parallel sides. In some houses, two of the sides of the roof are in the shape of a trapezoid. If the parallel sides are A and B, and the altitude is h, remember that an altitude is the height, the area is given by A equals h over 2 times quantity A plus B. Solve the equation for A. I'm going to go ahead and rewrite my equation. A equals, I'm going to write this as 1/2 h times A plus B, just simply because I kind of like it better when I get to see that fraction pulled out in front. You don't have to write it that way. You can leave it as h over 2. That's all right. Now, we are being asked to solve for A, which is inside a quantity. You cannot do anything until your quantity is isolated, okay? You have to completely isolate that quantity before you can move forward and even think about touching that A. So the first thing that we need to do is get rid of the fraction of 1/2. To undo the multiplication of a fraction, we must multiply both sides by the fraction's reciprocal. So we're going to multiply both sides by 2/1, which is the same as 2. So we have 2a equals, they cancel, h over a plus b. Or excuse me, h times quantity, a plus b. We're getting closer. Now we just have an h attached to our quantity. What's happening between the h and the quantity? They are being multiplied. How do we undo multiplication? We divide. What am I trying to get rid of? The h. So we're going to divide both sides by h. So we now have 2a over h equals a plus b. Once your quantity is isolated, you can remove your parentheses. So once your quantity is isolated, you are permitted to remove your parentheses. So the last step here says, how do I get rid of addition? We subtract. So since we're adding b, we will subtract b from both sides. So we will just rewrite this last line as 2a over h minus b equals a. And there is your final answer. There is your final answer. And what that would allow you to do is once you are given a value for your area, your height, which is your altitude, and B, which is the long base, basically the ceiling of your house, you would be able to plug those three values into this final formula. Do one mathematical calculation and find the length of your roof, rather than plugging those values in to here, here, and here, and doing a ton of ugly manipulation, all to solve for A. So if you have any questions about what we covered in this section, please contact me. I will be more than happy to work with you and to help you through anything that you need help with. Thank you.